Hello, hi everyone. Today we will discuss very important syllabus of probability and statistics. In this course, one important topic we will discuss that is the regression analysis. The regression analysis is a really important tool for every statistician or non-statistician or other disciplines people as well. First, we'll discuss what is meant by regression analysis. Regression analysis is a statistical technique used to model the relationship between a dependent variable and one or more independent variable. In our life, whenever we gather data, it could contain more whether in the qualitative as well as quantitative data. We suppose we would like to know the relationship between one or more variable. We mainly focus on this technique for finding the relationship between the dependent and one or more independent. If you have a two variables, should one have dependent, another one have independent, we have a simple regression technique. If you have a multiple independent variables with the one dependent, you can go with the multiple techniques. We suppose that data sets contains some binary type. We can use the logistic regressions. Sometimes these data sets have a straight line pattern or linear pattern or nonlinear pattern also. So at that time, we can go with the nonlinear model also. Okay, this is a very, very important objective for this regression analysis. You have to understand the independent variable affect the dependent variable and also how to make the predictions, how to make predictions based on this understanding about the dependent and independent variable. First, we will discuss what is the simple linear regression model. Already I had told you what is a simple linear model. This model involves one independent variable and only one dependent variable. Okay. The one independent variable involves the predicting a dependent variable, and also we could find the relationship of this model, whether it should be a straight line or it should be a non-linear. Okay. This is the model equation y equal to mx plus b. Here y indicates for dependent variable and x denoted is independent variable. M is the slope and B is the intercept. So this is the general model. Then the next case, multiple linear regression model. In this model involves two or more independent variables predicting a dependent variable. And this is the model given here, y equal to is a dependent variable. Here, P naught is the intercept and B1, B2, B3, etc. Bn are called the regression coefficients. And these x1, x2, etc. xn are called the independent variable. In this model, we have used two or more independent variables. This is actually the general model. We can use two independent, we can use three binary bivariate model or trivariate regression model or multivariate regression model. We can use it based on how many dependent variables we have collected. And then the simple linear regression model and this multiple linear regression model, how to estimate these parameters, unknown parameters. What are these unknown parameters in this previous model? These intercept and slope, B and M. B and M. These are called the unknown parameters. How to find these unknown parameters using ordinary least square method. Why we use ordinary least square? Because we have a more model to estimate the unknown parameter. Example, the method of maximum likelihood estimations, method of moments. There are so many methods on that. Why purposely while using this ordinary least square? Because this model only gives uh, the unknown parameters values with the minimum error. The minimum, the least error it should be given for using this model. Here in this multiple linear regressions, we have n unknown parameters value depends upon the independence. Here we not intersect, then so many n number of regression coefficients. These are called the unknown parameters. This also we can use the ordinary least square methods for finding these unknown parameters values. Okay, these are the how to fit the model. Okay, how to fit the model. You have to choose the appropriate model and estimating the coefficients. These coefficients will use the minimum of difference between the predicted and observed value. That is called the error. It should be minimum. It should be minimum. That's why we refer the ordinary wireless method. The next step is assessing model fit. How to evaluate how the model fit of the data. Is it fit well or not well? Okay. And then how to measure that one? We can use the coefficient of determinations. How much percentage explained dependent variable in the independent cases. Okay, that is the proportion of the variance in the dependent variable that explained by the independent variable. This is one of the technique how to assess our model fit. Okay, whether it should that model should be a good fit or poor fit based on the coefficient of determination values. The next step is significance. We have to test the significance of the coefficients, the B0, B1, and B3, etc. In that simple linear model, we can use it. We can test the significance of the coefficients B0 as well as B1. In the multiple cases, the multiple regression also, we have so many coefficients B0, B1, B2, B3, etc. Bn. Okay. These techniques used for assessing whether the estimated coefficients are significantly different from zero or not. You can use a test as well. The next step is how to make the predictions. Once we fitted our model and validated, we can go for predictions for new values or unseen new data or unseen data.